Alkynes. Alkynes are hydrocarbons with triple bonds. Alkynes are also unsaturated compounds because it has a multiple bond. Alkynes forms a homologous series with the general formula CnH2n-2. Alkynes are more reactive than alkanes. A summary: alkanes, alkenes, and alkynes. Alkanes, only single bonds, with the general formula CnH2n plus 2. And then they have low reactivity because they are saturated. That means only single bonds. Alkenes have double bonds and the general formula CnH2n. They have high reactivity because of their unsaturation. There is a double bond. Alkynes has triple bonds with the general formula CnH2n minus 2. They have high reactivity because they are unsaturated because of the triple bond. Example 1. Draw the structural formula for these condensed structural formulas. For A, CH, there it is, CH. Another carbon atom, there it is, bonded to a CH3 group. Now, it is not shown in the question, but there has to be a triple bond between carbon 1 and carbon 2 for the carbons to have 4 bonds. And remember the golden rule, a carbon should always have 4 bonds. So this is the structural formula for A. Let's look at B. CH3, CH3, CH2, and another CH3 group. And C, CH2, CH2. Then a CH moiety, CH, bonded to a CH3 group. Now again, you have to realize that there should be a double bond between carbon 1 and 2 to ensure that every carbon atom has 4 bonds. Example 2. Complete the table. Here they give you compounds and then they want to know, are they saturated or unsaturated? That means, is there only single bonds or double bonds or triple bonds? So for the first one, CH3, CH2, CH3. If you go and count the bonds, you'll see that there's only single bonds, therefore saturated. In the second one, you can see the triple bond there. It is shown, and therefore you know it is unsaturated. For the next one, you can go and count your bonds. Here's a carbon with 3 hydrogens and a single bond to the other carbon, bonded to 2 hydrogens and then bonded to a CH and to another CH. Therefore, there should be a double bond between these 2 carbons. Otherwise, they don't have 4 bonds. This means that this molecule is then unsaturated because of the presence of the double bond. The next one, heptane. Remember, the suffix for alkanes is -ane. Therefore, you should know that heptane falls in the alkane category, which means it's got only single bonds and is therefore saturated. And for the next molecule, you can see there's a double bond, therefore unsaturated. Naming alkynes. The alkyne suffix is -ine. Therefore, at the end of the branch name, you get -ine. The prefix is then again prop, for example, 3 carbons. And then you can have alkyl groups. Example 1. Give the IUPAC name of this molecule. The first step is always to identify the functional group. The functional group here is a triple bond. Therefore, this is an alkyne and the end part of the name should be -ine. The next step, find the longest carbon chain. There it is. 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6 carbons. Therefore, it doesn't matter which, if you go the linear chain or the branch chain, you have 6 carbons in your longest carbon chain. The next step is to number your carbons. Now, if you number from the left-hand side, the green numbers, and from the right-hand side, the purple numbers, you will see that the triple bond, which got priority because this is an alkyne, is at a lower number if it's the purple numbers, 2 and 3. As for the green numbers, the triple bond is at carbon 4 and 5. Therefore, the purple numbers are the correct way to number this molecule. Remember to always number your molecule and choose the numbers which gives you the lowest possible number for the functional group. Now you have to look at substituents. There is one substituent at carbon 5. It's got 1 carbon, therefore methyl. And then the name will be 5-methyl hex, because there's 6 carbons, 2-ine, because the triple bond is at carbon 2. Example 2. Draw the structural and condensed structural formula for 6-methyl hept 3-ine. The first thing you do is you draw your 7 carbons. Why 7? Because it's hept. And now you go and look at the substituents and the double or triple bonds. So it says 6-methyl. So at carbon 6, there should be a methyl substituent. And 3-ine. So at carbon 3, there should be a triple bond to carbon 4. Now for the condensed structural formula. Now you look at carbon groups. Here is a CH3, CH3. Next, CH2, CH2. Then you have a carbon, 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 bonded to a CH2. There is your CH2. Then you have a carbon bonded to a hydrogen and a methyl group. There's the methyl group in brackets, and then your last CH3 group to complete the chain. Example 3. Give the IUPAC name for this molecule. The first step is always to identify your functional group. So this is again an alkyne because there is a triple bond. Now you find your longest carbon chain, and it doesn't matter how you count your carbons, it should be 1, 2, 3, 4, 5, 6 in the longest carbon chain. Now you number your carbons. If you number from the left-hand side, you have the green numbers. If you number from the right-hand side, you have the purple numbers. So, look at which numbers gives you the lowest combination, which for the triple bond is 3 and 4, but for the purple numbers, it is also 3 and 4. So now, how do you decide which numbers are the correct ones? You look at the substituents. The substituents are for the green numbers at carbon 5, but for the purple numbers, they are at carbon 2. Therefore, the purple numbers would be the correct ones, because then the substituents and the functional group are at the lowest possible carbon numbers. Since the triple bond is in the middle of the molecule, you move to the substituents and then you get 2 lower than 5. Now you look at your substituents. There's methyl at carbon 2 and another methyl at carbon 2. Then you can write down the name. 2,2-dimethyl because it's 2 methyl groups. Hex because there's 6 carbons. 3-ine because there's a triple bond at carbon 3. Thank you.